start recording and then share screen. Okay. So let's start with project. So I think the most difficult part about the first deliverable is, sorry, the first deliverable of project 2 is the API key, right? I think I got a couple of emails asking me what happened. You need an API key that's valid, and what that means is you might need credit card in there, depending on if you use up all the quotas or not. I mean, what's that? Right. So apart that, everything should be fine, right? Okay. Okay. Good. That's what I thought. But if you have any other issue, obviously just email me or let me know. I think pretty much the only issue is API key, and the API key is obviously a personal thing, right? Depends on the quota, how many quota you use. If you blow up the quota, obviously put a credit card number in there. Okay. So that's a project. And then the deliverable should be fairly easy. It's just like 3-4 questions. I think just 3 questions. And then if you can showcase that you install package, run through everything, make API call, then you're good to go, right? So that part should be very much straightforward. So with that being said, that's pretty much the first deliverable. If you already submitted, obviously you're good. But I think I made announcement that you have like 1 more week of deadline. If you want to fix something, please feel free to go for it, right? Okay, so that's about that. And then let me remind you where we are. So we've gone to project 1, which is the credibility score. Now we are in project 2, which I call it tiny troup, just name after package. But obviously we're gonna today we're gonna break it apart. We're gonna break it apart, and I'm gonna show you guys how you can kind of define something your own, and then you can basically have one API call invoking the other API call. And then hopefully I can show you a generic way to do this. And then what I mean by that is I'll give you the source code, and then I'll show you what the app look like. And then obviously you feel free to plug in whatever large language model that you want, right? You can go on Hugging Face, you can go different open source or different closed source, whatever you want. If you feel like OpenAI is too expensive, you can use Together.ai, you can use whatever other open source that you want. So that will be first part of today's class. And then that will give you guys enough resources and material for the next submission. So first submission is, here's agentic AI, here's how you make API call, you install the package, you're good to go. Second submission is, okay, you're trusting the package for the entire first deliverable. What if you take the package apart and you do something on your own? What would that look like, and how could things break? So that's deliverable number 2. Make sense? So we're gonna talk about that the first hour. We're gonna take a break, and then next hour, we're gonna go back to our slide, which is to continue with the deep learning portion. And then hopefully we'll kill as much slides as we can, and then we'll leave the rest of the class to be Q&A. So that's the plan for today. Any questions? Okay. And then another housekeeping item I want to say is, I think the second week of May is finals. So I'm going to try to do my best to not overlap with the finals with the existing students, with the existing classes that you guys are taking. So I'm going to try to figure something out to hopefully end everything before before May. So the last week of April, I'm hoping to end everything there. And then what I'm hoping to do is there's going to be some sort of presentation. The presentation I'm thinking about doing remotely, because then everyone can share their screen. It'll be an independent project. It'll pretty much be, I want to make it optional. So you can demo your project too, or you can demo your own project. I'm obviously going to tell you guys what that means, and then give you guys like a detailed instructions to do that. So that's upcoming. And then another thing I want to announce is, I think a couple of you are working with the startup that I mentioned in the beginning of the semester. Please continue to do that. Definitely that will act as a bonus. So bonus means that if you're like A, I'll bump you up to A+. If you're A-, I'll bump you up to A. Make sense? And then one last thing I want to say is housekeeping item is, I think most of you are doing fine in this class. I wouldn't worry too much. Like end of this week, I'm gonna check everything, and then what I'm gonna do is this. It sounds scary, but it really isn't. What I'm gonna do is this. I'm gonna look at the grades and the distribution and then see what's going on and then try to give you guys some feedback. If you haven't received any email, it means you're okay. You're like A minus or above. If you have received email, that means something's wrong. So like if you're doing well, you get an A minus or above. Like I'm not gonna send an email and say, hey, congratulations. I want you to work hard, right? But obviously, like I look at your submission and then if you need help or if you, for example, API call, or if you don't know how to put together a Python app or something like that, see you get an email from me, and then we'll see how to catch you up with the class progress. Does that make questions? Okay. Cool. So those of you who are in Zoom session, just make sure email me because I might not be able to see the chat when I'm talking. Okay. Let's come to the project a little bit, and then we're gonna help you guys understand what's going on. So let me take your attention to here. This package, Tiny Troup. Oh, I didn't mean to do that. So this package, Tiny Troup, it's designed kind of like a wrapper of OpenAI API call, and what that means is based on the content that you talk to the chatbot. Excuse me, I shouldn't say chatbot. Based on the content that you're entering into the package, it's going to trigger like a list of things, like list of actions. Like for example, think is an action, or for example, talk is another action. And these can all be designed. Same thing, you can have action to be, say, running Python code, right? And then I kind of want you guys to think about that because the last deliverable of project 2, which you can, of course, use as your final presentation if you want to, there has to be some sort of data science part, right? There has to be some sort of machine learning part, which means that API call need to be very well designed. Because you don't want to show some demo and then something break. That's going to be awkward and embarrassing for you. So I'm going to obviously show you guys how to do that and then how to like guardrail everything so everything is good to go, and then hopefully you don't break things. Unfortunately, Tiny Troup doesn't do that, right? Tiny Troup is purely language based. Like there's a string in, string out, string being printed on the terminal window. Other than that, there's not so much going on behind the scene, right? So that's why we want to do what we want to do, which I have this app design. Let me just show you what it does first, so you guys get an understanding of what's going on. It's a live open source URL. It's on my Hugging Face. It's called Dual Agent Simulation. It's connected with a hyphen in the middle. So what this app is doing is the following. Let me just show you. So let's say you enter a topic, data science, and then you can run simulation. What it's going to do is it's going to trigger 2 robots talking to each other, and then they're going to carry out a conversation, and then the conversation is going to stop somewhere. So this is the caveat. A lot of people look at this, and then a lot of people think, oh, you just have an API call calling another API call. That's actually not how it works. You actually have a third API call, a third agent called AI Judge. And the AI Judge tells you when to stop the conversation. Does that make sense? Otherwise, you just have 2 agents that's talking infinitely, and that's not going to be good. So let me zoom. Let me start. Let me just walk you through like maybe the first 2 sentences. Ask the questions about the topic, data science. Data science is a topic that I entered here. If it's not data science, you can enter whatever you want, right? Quantum computing, Gen AI, whatever you want. And then the first question goes, what are some of the most effective ways to handle missing data in machine learning models? And how can data scientists ensure that their models are robust to missing values? And then the answer starts with, yeah, so missing data, right? It's like a super common problem in machine learning, but like not everyone knows how to handle it, something like that. Now, either you like this answer or not, right? Let's say you are kind of okay with the answer. Come on in. Let's say you think this answer is fine, but like not perfect. Let me give you a contrast of if I scroll all the way down here, you don't need to read it thoroughly. You can just look at how the answer is presented. You can kind of see it gets more structural, right? I don't need to read anything. I already know the answer is more structural. So this last one comparing with, again, if I scroll up, the first one. Does that make sense? So in other words, what's happening is as this agent is carrying out a conversation, it's changing its behavior in a way that it's trying to get better. And you have the control to tell it what better means, right? It's not like agent is something, right? It's going through a certain agenda that you define. Okay, so in other words, what I mean by that is on the surface, it looks like two persons talking, right? There's question, there's answer, and if you scroll the question, there's answer, right? But the trick here is this. That's why I have this drop-down button. The trick is this. If you put the drop-down button, you realize it's actually a judge comments. So let me hide the sidebar just so everyone can see what's going on. So this is a table format of pretty much all the conversation aggregate together in the backend, right? So question, put a question there, answer, that's answer there. And then this judge gives effect. The judge says, okay, the answer lacks clarity and structure. So that's what's happening there. And the next round, this agent that's providing the answer is going to try to learn from the judge comments, and then it's trying to pass a score. There's a hidden score here based on comments that I don't really have to tell you on the user interface. On the user interface, you don't see this thing. On the user interface, you just see two people talking, and then somehow the person that's answering the question start making some changes down the road, a couple of conversations down the road. Does that make sense? So this, it's kind of like the same idea. Like if you go to, I don't know if you guys know this, a recent Chinese company called Manas AI, and Manas AI is doing pretty much the exact same thing. So you can say, let's say you want to, let me show you this one. This is a cool one. So you can talk to a chatbot, and then behind the scene, Manas AI is actually able to generate code, generate command line interface, generate a terminal program to run in the back end. And then each program is going to invoke another program. And then instead of having, instead of what Tiny Troup is doing, that have string going in and string going out and string printed on your table, what Manas AI is doing is, for example, there can be an agent that's running terminal command. There can be an agent that's running Python command. There can be an agent that's generating plots, right? These can all be defined simply based on what you want and how you envision what the user is doing. I think, is this almost end? 11, 12, I think it's almost to the end. And then in the end of this, what's cool is they actually have, they're actually able to stand up UI for you to summarize what is it that you want. So I think you can probably click on this. Let's see. Yeah, so you can click on this, and then this UI is generated completely on their own space, on their own cloud platform, such that it pretty much does the analysis for you, and then the user can then basically just read it and take it to go. Does that make sense? So if you understand what's going on today, it will be really easy for you to pull this off. It'll be really easy for you to pull this off if you understand everything that I'm talking about today. So let me take you to the back end to show you what this means a little bit. Again, remember, like, keep this table in the back of your head, because this judge and comment thing is going to be important. So that's the user interface, that's UI. Now let me take you to the code. The code is designed this way. Let me show you the front end. Front end is essentially a Streamlit application, meaning that it's a Python based, and then you can just do this in Python in one language, right? Front end, back end, it's all Python. Sidebar is sidebar, nothing to be said there. Sidebar is sidebar, just instructions and things like that. And user can enter a topic, right? Keep things simple. In this case, user can probably enter. Right? Tell me stock price of Tesla, or give me a dashboard of Tesla, right? Something like that. So in that case, so it's the same thing. User has to enter something, right? Give you something to do, and then you use that as a key, and then you start generating your own story, right? And then the API calls starting to call each other. So this is a design. When the submit button is pressed, it's gonna start trigger a list of actions. So number one is there's an interviewer, take the prompt, and then the interviewer generate a question, right? So immediately, what is interviewer? Well, let me show you what that means. So to do that, let me open this as a new tab, and then let me go to utils, helper. Let me go to let me show you this first. This is just a generic API call. Llama 3, nothing special there. It's a generic API call on Together AI. I did this on purpose because I want to show you can do a different way other than OpenAI. If you have a problem with OpenAI, obviously you can use Together AI, same thing, right? So really that's just, you just need one API call and you can pull this off. First things first is, I think I defined the interviewer. So let me show you this. So interviewers is defined as an API call, as simple as that, right? And an interviewee is also defined as an API call, as simple as that. Judge is defined as another API call. So essentially these three things are just a generic call Llama API. It's literally just copy paste these three lines. Nothing special there. You can of course do a little bit of a prompt engineer to give the judge a little bit of different persona if you want to. You can let the user to give judge a different persona if you want to. But the design is fairly simple. You have three API calls. The interviewer is going to take prompt and start asking a question. And then once you generate that question, this becomes an input to the interviewer. The interviewer in this particular case is going to take the worker way. But run design now learn from judges on line one. It's a very maybe I can say a very naive design, and even the iteration here, you can see I'm like literally hard coding this. In the question in a mediocre way, you
Professor, we are unable to hear you.
oh sorry. There's one thing that I found interesting is it always ends on, I think, let me run the simulation again. Based on my experience, this always ends at a fixed number. Like if some of you figure out a good explanation of why that happens, it'll be a pretty good paper. So let me just let this run a little bit, and then once it finishes, we'll count how many rounds there are. But based on my experience, I think it always ends on like maybe like 7 or 8 or something. Like somewhere down the road, it just magically finishes, and it always finishes on that number. My gut feeling is probably has something to do with the temperature and like the top P or top K. That's the parameters that you send into LLM. Which obviously I did not define that clearly here. I think everything is just generic, like whatever this is. I think it might I think it might be related to that. But those things all play in a role of how you control the length of the conversation, right? Think about it. If this minus AI's case, like if this is a recorded thing, right? Because they demo this to be like from here all the way to here, right? However long that is. Let's say that's 10 minutes. 10 minutes, you're probably going to be waiting for that. Fine. But if that lasts like a day, you're going to run out of patience, right? And how do you control that? Well, you control that by running the simulation like this and see how much it ends. Is this end or no? Yeah, it finishes. Let me see if I can get a count of this. Yeah, somewhere down here, I should say. It's 8 here. So I think, I don't know if it's going to keep generating, but I think somewhere here it's going to stop and it's going to land on 8. And then it's no longer going to continue. Does that make sense? So a little tricks here and there will affect the quality of the conversation. So let me take a pause. Any questions here? Okay. This is one thing. And then another thing I want to show you guys is running the Python code in, excuse me, let me rephrase that. Running the Python script in Python. What that means is you use a package called subprocess, right? And then I have something here that I want to show you. Let me go to my docs, and then deep learning. I have a file here that I want to share with you. It's Mistral AI, and then I think it's this one. Let me see. It has code to essentially show you how to run the bot to generate Python code, and then to, I think it's this one. Sorry, it took me a while to find that thing. It has code to help you to basically teach you how to call an API to write a code and execute the code for you. So that package here is called Wing Agent. It's actually pip installable, but I prefer you like break it apart and then put it in your own code, right? So how it works is this. When you look at the prompt that's coming out of ChatGPT, if it's a code, if it's a script or code or whatever, SQL or Java or whatever, you usually get this ... and then says Python, or ... says Java or something like that. And then what that means is you need this function called isolate and save Python code to basically use regex to split out the response from code to text. Does that make sense? And then all that stuff is done in this helper function called isolate and save Python code. And in terms of how you code it, it's actually just to use regular expression, right? Use RE, that's the package, and then you search for some sort of pattern. In this case, I did using Python because Python is the most popular one. But in your case, obviously, you can make it more generic and make it more soft-coded by using Java or SQL or anything like that. Literally, you just take this Python and swap to Java or swap to SQL. Then this function should be able to run and isolate the Python code or SQL code or Java code. And then you can kind of like execute that against some sort of database or run that sub-process in the backend. Make sense? So that's number one. And then number two is you execute a Python script. In this case, again, I'm assuming it's a Python. So this script, obviously, assuming it's a Python script. And then you use this package called subprocess. Subprocess, it's basically like a command line interface that executes the Python script in the backend in the Python environment. So it's kind of awkward to explain that. Like you're running Python using Python. Does that make sense? So that's what this line is doing. It's running that Python script, and whatever's coming out of that Python script, you obviously want to capture that result. And then whatever that's being captured, then you save it. This also assumes that if you are running a Python script that you did not print things out, then obviously it's not going to capture, right? So what that means is whatever the code generation agent that you are using, make sure you engineer the code in a way that will give you that print statement so that you can capture the results in the end. If there's no print statement in this script, then this result is going to be blank. So that's another thing I want you guys to know. And then once you have this, this is the script that will do the job for you. So you will start a conversation, and then the human will take a prompt from the, the bot will take a prompt from a human. And then you start generating the response. This is just an API call that you call in this case, it's Mistral AI, because that's another example I want to show you guys. And then if this pattern of $.python happens or shows up in the response, then you can do certain things, right? You can isolate it. You can ignore the input. Input just means I want to save it. This is how I designed it when I was designing it, because I want to be able to track each script. You can leave that to the user, no problem, or you can just simply omit it. If it's just a singular one API call, write this Python script and execute it. You don't really need to give a name or something like that. If $.python is the pattern that appears in the response, then you run the helper function, isolate the Python code. Once you isolate the Python code, then you can execute it. So this block of code essentially execute the Python script, and whatever the output is will print it out on your computer. And you can do all of that in a Streamlit application. Does that make sense? Any questions? Okay. Let me show you what the end product look like, and then I have to find this out for you. Hang on. I put this on Azure, and then I'm hoping I'm sharing screen, right? Okay. So hoping this works. Where is it? Give me just 1 sec to pull this off. I tried this literally 2 days ago, and still be able to work on. Okay, so the backend is Streamlit, right? It's just a Python script in the backend. The only thing I did special here is upload the artifact of Streamlit and push that onto Azure Cloud, right? Azure Cloud is the same thing as AWS. It's just the Microsoft version. And then I have a page here called Python bot. The Python bot does pretty much exactly what I just said, right? So you can say something like, let's start with something everybody knows. What's the number? And then what's happening here is it's going to make an API called the Mistral AI, and then the Mistral AI is going to try to write some code, and then I want to execute it, right? Here, once you write some code, whatever is in here, you don't see that right now because it's rendered using Markdown. But behind the scene, before this Python script, before this DEF, there's .python. So then it's asking me name this Python script. I'll say test1. I'll hit enter. And then it shows up this button, and I just say execute. It's just press the button. So once I press this button, I gave computer the permission to execute it. And then the output of executing the script is 5. Does that make sense? So then that's going to be the Fibonacci, the 5th Fibonacci number. And then it should make sense because if you count it, I think it's this one. I don't know if people count 0 or not, but it's supposed to be like this number here. Does that make sense? Yeah. So this has a running Python script behind the scene. And obviously, I'm going to show you guys all the code. So here is what the deliverable 2 and 3 look like for project 2. So deliverable 2, hopefully you can reproduce this. If you're able to reproduce this, you're good to go. What's that? I was thinking about reproduce an app. You don't have to do an app if you don't want to, but at least reproduce the logic. Yeah, the Streamlit is just to make everything easier to read. But if you want to produce in a way that I did here, where did it go? If you want to do it like this in a Python script, that's perfectly fine. So this script you can run in Python or run in a terminal. You have a conversation and you will execute the .py script in the backend. So if you want to do this way, no problem at all. This way, there's no Streamlit application. You can bring everything on Streamlit if you want to. It just looks different, but the logic is the same. I care more about logic. If you can reproduce the logic, then you're good to go. So deliverable 2 have 2 versions, as what you said. Version number 1 is do everything in Python. Forget about Streamlit. Do everything in Python. You make an API call to an agent. The agent can then say, here's the code. You isolate the code, run it. Here's the results, right? Or same logic, but do it on Streamlit. So that's deliverable number 2. Deliverable number 3 is same thing, but that Python script has to have some sort of machine learning component involved. So this means everything that we talked about, logistic regression, linear regression, decision tree, neural network, you can then have an agent to execute all of that behind the scene for you on your behalf. And that will be the third deliverable of project 2. Make sense? Any questions? Okay, good. And then let me say a few words about the third deliverable since we're here. The third deliverable has data ingestion. Obviously, you can't build a logistic regression model if I don't give you data, right? You have to have data somewhere. So where does data come from? I think there are 2 ways you can do about it. The easiest way is you have a CSV file somewhere locally, and then you just say hard code it. That's a CSV, run a logistic regression against that. But the problem is you're gonna have to tell the user what the CSV is to be able to allow user to say something appropriate, right? What if I say something that says, oh yeah, use Y column in a CSV to build logistic regression? Well, what if the CSV doesn't have a Y column? What if the CSV's column says housing price? It's not called Y. Well, obviously that's going to be a mistake, right? Obviously it doesn't run that code. So a little tricks here and there. I count on you guys to hash that out in the deliverables 3, because that's the whole project. It's the ability to think about the details of data in, data out from one API call to another, and how to make it bug-free. And then the last thing is the ML solution. Obviously, the more advanced ML solution you allow user to ask, the higher your point will be for the pretty much entire class, if you can pull that off. Meaning that everything we talked about in the past, it's a fair game, right? You can talk to a chatbot, and then you can have chatbot to read a CSV, and then you should be able to let the user decide what problem the user wants to ask, right? If it's a housing price, the user should be able to say, I want to run a regression model, and your code better works. If your code doesn't work, then obviously, it's your problem. You have to fix that. Or if the data doesn't really have a categorical variable, and then users say, I want to do a categorical variable, or I want to do a classification problem, your chatbot needs to be smart enough to figure that out. And the tools that you have today should be able to help you to do that, right? So the bonus point for the third deliverable is how you get around users' inappropriate questions. If user asking you something just completely wrong, Like I want a logistic regression on housing price. Well, that's wrong. That's just a wrong question. Housing price, it's a continuous variable. There's no logistic regression to be talked about because logistic regression requires categorical variable. So is your chatbot smart enough to get around that, right? That would be based on your design. So that would be deliverable 3. So in other words, long story short, deliverable 2 is replicate this. Deliverable 3 is how do you get around with someone just doesn't know how to ask the right question. Cool. I think that's pretty much everything I want to say about deliverable 2 and 3. Any questions about what I said?
So what's this connect?
So Tiny Troup has two API calls back and forth, very much like this app. That's pretty much it. There's no agent. There's no API. Excuse me. There's API call behind the scene, but there isn't the calculation part. The compute is not there. It's just a string in, string out, string being printed on your computer. What I'm saying here is we can use this framework to see what's inside of Tiny Troup, and then be able to customize what Tiny Troup is doing by not just only have a string in, string out. What if in this case you have a CSV in, right? What if in this case you have a .py script going in or .py script coming out, right? Like for example, to do this button or to do this download button, this actually allow you to download a .py script that's completely generated by AI. It's not written by human. So how do you allow that data transfer from one service to another? So that's being built upon Tiny Troup. It doesn't use Tiny Troup directly. I'm using Tiny Troup as an analogy. Yeah. Yeah, that's a good question. Any other question? Yeah. So here's what I'm thinking. Because this is already like the last week of like March, right? So next time we come here will be April. What that means is we don't have a lot of time. I want to wrap everything before April, so we don't have overlap with other exams. So what I'm thinking is this. The general requirement meaning you're not working with startup, you're not doing this and that, right? The general requirement for normal students is you have to submit all the way to deliverables 3 of project 2, and then you give a presentation on the deliverables 3 of project 2. And then the presentation I'm thinking about doing remotely because like I don't want 20 people to come up here to share the screen. It's gonna be a disaster. So it'd be easier to just have a Zoom call and then everybody just share their screen. It'll just be easier that way. I haven't hashed out details because obviously there's gonna be a lot of common ground between every student. So I'm thinking about like for example, half of the class show up like the first hour, half of the class show up like the second hour. So you see, I mean, you're welcome to stay the whole time if you want to. But you don't have to. As long as you show up and then you did your presentation, then I can evaluate how you perform in the class, right? Obviously, there's some live interaction. It's not just going to be you walking through Python script, right? There's going to be live interaction, meaning that you have to demo something. It can be a Python code. It could be a Streamlit application. I'll leave that to you. But the chatbot needs to have some sort of answer back, right? You can't build a chatbot, the chatbot doesn't say anything. Well, that's going to be a problem. So hopefully you prepare at least a script that you tested yourself, and then you know for sure that these couple of questions will work, so that I know you did something that it works, right? And I'm going to ask a question and have you type in your chatbot and then see if we break it. Hopefully it doesn't break it. That's going to be what the presentation is about. And then in terms of details, you can probably think about something like, let's say every person gets 7 minutes, share your screen on Zoom. Let's say 5 minutes of presentation, and then we leave 2 minutes for me to ask you questions. Cool. So did that answer your question? Perfect. Any other question? Yeah. No, you're not required to do the final project. I have a final project on GitHub that I just made optional. If you want to do it, let me know. And then obviously I can share with you what needs to happen. You don't have to. I'm thinking about having the because when you give final project, it has to be like a base level, right? It can't be like like I'm going for the level that everyone can do. Like I'm not going for the level that the only one student can do, right? So so I can at least give an evaluation for every single student fairly, right? But that being said, I want to also make it flexible. So if you don't want to do the deliverable 3 or project 2, and you can make a decision to do your own project or project 3 or the startup project you're working for, it's no problem at all. Please try it. Yeah.
Please option for everybody.
Yes, it's an option for everybody. So if you hit deliverable 3 or project 2, and then you know exactly what's happening there, then you're good to go. And you can just present that in the final project. Make sense? Yeah. And final project, I'm like 95% sure it's like gonna be Zoom because it's difficult to get everybody in one room and then have someone come up here and then share screen. Yeah. Any other question?
So just to
Yeah.
to be able to
Yeah. Run it. Save and run it. Yeah.
3 is
Correct. Yeah. I mean, if you want to make it even smarter, you can build a AI judge inside of a deliverable 3, and then have the AI judge evaluate whether the code is doing what it's supposed to do. Like if you run a linear regression and then the R square is 10%, then the AI judge should be able to say the R square is too low, you should add polynomial regression, right? And we talk about polynomial regression in class. So that knowledge, even if chatbot doesn't know it, you should be able to know it, right? And then we also talk about like decision tree, right? Support vector machine, we talk about all of that. So, and we talk about the pros and cons. Like there are things support vector machine can do that other algorithms cannot do, right? There are things decision tree can do that other algorithms cannot do, right? It'll be even more interesting if you can design a chatbot in a way that solve a particular problem. So what I'm giving you is a general framework. It'd be really interesting if you can design like some sort of like a graduate research assistant sort of chatbot that says, hey, here's the data set. I want to define, I want to do my own thing. Like eventually professor wants to do their own thing, but they can't because they don't have a benchmark result, right? So then you take the data set, define X and Y, send that to lazy predict on scikit-learn. Lazy predict will write a box, give you like 20 algorithms. And I say 20 algorithms, these are accuracy, this is accuracy. We talk about lazy predict, right? Literally just one API call and you get like 20 results or something. So you can build the chatbot to benchmark the ML performance for the professor. It's kind of like it's like a generic thing that the research assistant do if you work with a senior professor, and then they probably have you benchmark. I've done that myself before when I was doing grad school. I think that part of job can actually very well be replaced by like agents right now. So if you can pull something off like that, that would be really interesting. It again, it depends on your knowledge of Python and how you work around the caveat situations. Like for example, what if the CSV has holes in there, right? What if one column has a null value, and then somehow linear regression doesn't take null value and give you an error, right? Like there are these little things here and there that you won't know of unless you try. Any other question? Cool. Okay, so let's take like a 15-minute break, and then it's 6:58. So let's come back at like a 7:15. And then we'll continue with the slides. Cool. So let's get started. Let me share my screen, and then yeah. So someone asked me a question during the break. I think I mentioned this thing in the beginning of the semester, and then there's like a Jupyter notebook that you can use. So the expectation for the deliverable here is I'm hoping you can build upon this current code, not just to install as a package. Does that make sense? So if you can build around this code, then you don't have to limit to Mistral, right? You can use together, you can use other things. So that would be one thing you can do. Another thing is the data ingestion. This code right now doesn't have data ingestion that's clearly defined. You kind of have to rely on user to say, okay, in this folder, there's a CSV. This CSV, it's named test data CSV, something like that, for this chatbot to realize that. It doesn't know that off the bat. Or you can think about like some sort of a directory scanning process. Yeah, like a file picker. Yeah, to build inside of this, right? There are like a million ways you can customize this. This is just a very, very general template. Does that make sense? So another thing that someone else asked a question, which is the deliverable. So I don't think API key is a huge issue, or at least for people here, I don't think that's a huge issue. So the next Tuesday, the submission will be deliverable 2, which is to basically replicate what I'm talking about today. Meaning you can have Python code running in terminal, or you can have a Streamlit application. Either way is fine. For third deliverable, it'll be in 2 weeks. Not gonna. No, I meant 2 weeks after next week. So I want to give you guys 1 more week to do the third deliverable. Does that make sense? And then there's another 2 weeks after that to do the final project. So you should have 4 weeks after deliverable 2 before the presentation. Make sense? Let me pull out the calendar just so everyone know what I'm talking about. Can you guys see this? Okay, so next Tuesday, like today is end of March, right? Next Tuesday is here, April 1st. So April 1st is going to be deliverable 2. Deliverable 2 basically is you can put together a system of your own. You can literally just pull this code and run it in the terminal if you want to. So that as long as you can demonstrate that you know how to make an API call, and the API call can run some sort of Python script. Like those are 2 basic things. I don't care how you do it. You can take my code, or you can copy, or you can ask ChatGPT. As long as you demonstrate you understand that, then you're good for deliverable 2. So deliverable 2 is a very small ask. Deliverable 3, which is going to be in 2 weeks. So 1, 2. Make sense? So it's going to be 15th. So you have a little bit more time to work on whatever it is that you want to do. And then the presentation, I'm thinking about setting it maybe on 29th, just so that like you have like a bit more time to work on. And then unless like I'm assuming this is going to be in class, so same time except it's on Zoom, unless someone in the class can't make it or something, and I have to make a change on the schedule. But for the time being, just assume it's on 29th. Unless someone tell me otherwise, they're sick or something, that they can't make it, then we'll do maybe the weekends before and after, or like somewhere here or somewhere here. But for time being, just assume it's in 2 weeks on Tuesday. So we still have the class time, and so hopefully everyone has that schedule block on their calendar. Make sense? And then in that nature, obviously everything will be done by 29th, and then next week you guys study for final. So any questions? Okay, cool. I'm gonna type this up and send out announcement. So if you forgot what I just said, don't worry about it. Okay. So I think that's all the housekeeping item. Now let me start with the lecture. Let me jog your memory just a little bit. So right now we are in here. deep learning, right? So previously we talked about all these weird things of convolutional neural network. And then when I say weird, I meant that all these design, it's essentially just iteration on whatever trick that other people have done, right? So the trick can be this arrow. This is called identity or a skip arrow, right? A skip design. The skip design actually it's in transformer today. So it's a very widely used design, and people don't really. I think you should probably give credit to RaisinHead, but I don't think anyone from OpenAI will credit this paper anymore. But the skip design is a very interesting design to prevent overfitting. So obviously you should know that. And then if you, let's say you design a chatbot that builds a neural network model, and then the performance is not well. What if you build an AI judge that reads the output from previous chatbot and then say, okay, let's add a skip design somewhere in the middle. And then you can have a code generator to give you a new neural network code using TensorFlow or Torch that adds this thing in there. You can pull that off right now in terms of the agentic framework. So these tricks and these bells and whistles are pretty much all up there. Same thing. If you want to iterate 20 times, it's up to you. Right? People do that. If skipping once is good, then why don't you skip every single step, right? Why don't you just skip 1 step, 2 steps, 3 steps, and so on and so forth, right? And again, people do that. If you do that, that's called denseness, right? Don't ask me why. Right? There's absolutely no reason why that works. It just happened to work on that particular data when they wrote the paper. So same thing. If you can go straight, and then you skip n times, and then the performance is better, and that hits a bottleneck, then you should go sideways. Does that make sense? So that's what inception model is doing. So inception module says, okay, let's go sideways. And when we go sideways, let's use different configuration for the convolutional layer. Right? You can use 3 by 3, you can use 1 by 1, you can use 5 by 5. Again, is there any reason why this actually have to perform better? Not really. It's just the design happened to be better on the data set that people use. So all these tricks are here and there that you can build in the AI judge. And then the AI judge can then look at the performance, look at the network design, and then make recommendation on what you should be doing. And then if you're doing the research assistant agent that I mentioned before, then all these tricks, you can design that in AI judge. So that's pretty much it for up to convolution neural network. And then today we're going to kick off recurrent neural network. Recurrent neural network, it's the foundation for understanding how to build neural network for sequential model. And when I say sequential model, I'm talking about the data set with timestamp. I'm not talking about the sequential API, right? The sequential API has nothing to do with sequential model, just so you know. So what I mean by that is this. This is the diagram for a very basic generic recurrent neural network. There are 2 ways to draw this, right? There's one way on the left-hand side of the equal sign, and there's one way on the right-hand side. The left-hand side, it's also called the folded approach to draw the RNN, whereas the right-hand side is expanded, right? So depending on your background, if you're talking to a mathematician, they will probably prefer the left way, because left way, it's the same way as drawing a Markov chain. But if you're just talking to normal people, they probably understand it more if you show them this graph on the right, right? Mathematically, they're doing the exact same thing. So how it works is this. You have a sequence of data coming in, and then that means you have x1, x2, x3, something like that comes in to the neural network. And now the first thing is going to hit these nodes in the middle. These nodes in the middle are your generic logistic regression design, right? Nothing special there. It's a linear transformation, and then you activate it with a nonlinear function, ReLU, sigmoid, right? You get the idea. So once you have the value going into this node and coming out of that node, that's it. That's the end of the story. That's the output of the one node, and then you can use that one node to make a prediction, and then you can benchmark this output with ground truth y, and then this ground truth y is whatever you presented in your data set, and then you just fine tune the weights, and the weights are the W's and B's and U's. These are the weights. that goes into the model, you can change W, change U, change B, so that this output O gets closer and closer to Y. So that's essentially the logic there. So the forward propagation, or also known as forward pass, is from X to this output Y here. So go up. Backward pass or backward propagation is you go backwards. Go backwards means you look at the Y and then you look at this prediction, and then you run it through the loss function. Loss function, of course, based on the problem statement, based on whatever you pick, chances are it's going to be some sort of cross entropy. So you look at cross entropy. If error is too large, then obviously you can take the gradients. You can take gradients of the entire loss function with respect to B, U, W, these parameters like that, so that you know how to update these. And then when I say updated, the generic way completely applies. So the gradient descent all applies. So that's essentially the story here. Let me show you the formula. So this is the formula that goes into a node in the middle, in the hidden layer. So these guys here. So these guys here, that's basically this formula take the X, which is the information, and sends that X through this equation. And what comes out of that equation is going to be in that purple circle, in this purple circle. So if you just look at this a little bit, it's basically a linear regression model. And there's nothing special about that. Then two numbers multiply and then add each other. And that's pretty much it. These W's in the beginning, you can kind of think of that as like an intercept of the linear regression model. And then these A is the previous state. So that's the only thing that's different from a conventional machine learning problem. A conventional machine learning problem will take the feature, build a linear regression, and be done with it. But this is not, right? This is a recurrent neural network, meaning that whatever that this node predicted previously, let's also use that in our model. So in other words, if this ALK is stop price, you can think about this AL minus 1, comma S as stop price yesterday. So that's kind of like the analogy there. Why? Because we're talking about sequential data. Sequential data means time series. Like if it's stop price, then there's going to be a T minus 1. There's going to be a T minus 2. And the T minus 1, T minus 2 now becomes features when you're at T. So right off the bat, the time series people don't really like this because time series people respect random walk. And then most people in asset pricing or most people in financial market respect random walk. The people who respect random walk, they have a huge problem with this. They're like, what's the point of this? If random walk is true, which we believe it is true, then you should not be getting any information from historical data. So why on earth do you want to use this feature? What? Exactly. So it's kind of like fitting on noise. So that's just an argument, right? Obviously, that's just a school of thought, right? There's the other school of thought, which is the market is not efficient, which means random walk is probably wrong. And then you can probably still make money out of the historical information, meaning that there's something historically that somehow that the market doesn't know. And that's another school of thoughts. And then obviously they are the school of thoughts that claim they can make money. So those people will probably love this model. So there are people who love the model and people who hate this model. Does that make sense? So any questions? If there's going to be an exam, which there isn't, but if there's going to be a final exam, I'm almost guaranteed that there's going to be a final exam question here about the second term, which is to ask you why recurrent neural network is different from conventional neural network. And the difference is not only are you using X, which is a feature provided in your data set, you're also using historical prediction as your feature. So not only are you using companies' financials as your feature to predict tomorrow's stock price, you're also using yesterday's stock price to predict the future stock price. So that's what the second term is doing. So it's same logic here. when I say stop price, I'm talking about just as analogy, right? Obviously, it applies in other time series, like the temperature, right? Then this will be yesterday's temperature. Obviously, you want to know that, right? Like if I'm in the summer, and I'm using let's say I'm in June, I'm using the yesterday's last month temperature, May. Obviously, you have a better shot to predict July's temperature than if you use January, right? So that logic should make sense. So that's why this term, it's better if you, for the time being, right? Let's say we don't know any other LLM, we don't know any other model. For the time being, if I just show you this, your intuition should be, it'd be better if this A is near right now. It's close to today. Another argument is, if you are predicting something that yesterday matters a lot, temperature, right? Yesterday matters a lot, or sales, yesterday matters a lot, or last quarter earnings matters a lot, then your argument should be, okay, let's design the RNN such that this K, it's a little bit, excuse me, this A has as close as to the present as you possibly can, right? So that argument, of course, depending on your data, makes sense. The temperature data will be different from stock data, even though the mathematical model looks the same. Any questions? Okay. Yeah, I have a small note here, indicating that the weights will be shared. Like every layer, the W, U, and B are the same number. It's not like second layer, W, U, and B become different number, or like a different sets of number to fine tune. No, W, U, and B are the same sets of number. Just so you know. This is one way to write the loss function. So if it's a regression problem, which typically when you teach this kind of setup, you start with a regression problem. So you don't make assumption of which category, which class is. Just a prediction. That's it, right? Then the loss function is your usual square loss. So you take your ground truth, you subtract the output, and then you take a square. So that's a square loss. And then this square loss, if you think about this OL, which is the output, since the output is a linear regression model of all the historical nodes together, then you can loosely write it in like this. In this case, since this OL is a capital L, you are assuming this is the last layer. If it's the last layer, by definition, there's not going to be any X in there, right? Because the X already gone through the hidden state. So this equation, there's no X in there. So this OL, you can swap it with this linear model that now the feature is the hidden state, no longer the X now. And then you plug this back in this loss function, you expand it, it will look like this monster down here. Again, this is just a mathematical description of how, like, from technical perspective, how you train a model. Of course, you don't have to memorize all that notation. This is just for you to understand mathematically how things are done. That's pretty much it to understand recurrent neural network. So after a recurrent neural network, people have the understanding of how to handle time series data, right? But now there's another problem, which is what happens when you have words. It turns out that when you have words, it's actually a completely different story. And it turned out that this doesn't work anymore. And the reason this doesn't, actually, let me take a step back. Question, why do you think it doesn't work with words? Why can't this X just be a word and then just guess the next word? That's a good guess, but the design has no, it's not the key here. There's another thing that's the key here. Yes. You are going in the right direction, but why would that fail? Words are not numbers. That's correct, right? That's correct. That you get partial credits for that. But why would that fail? What's another word for non-sequential? So so combine the two of answer, you get it. So words is in a dictionary, right? Words fall in a dictionary. So a dictionary has index, and when you trace the index, it's not sequential. It's cyclical. It's a cyclical pattern, meaning that there's only fixed number of English words, unless tomorrow Gen Z and Gen Alphas are giving us new words. Like Riz is a new word I learned last week. That I'm so old, I don't know what the word Riz means. So apparently Riz is a new word now. If Riz got written in Oxford Dictionary, then the dictionary will be longer. Then that cyclical pattern will be broken for today's LLM, right? If you have 10,000 words and you add Riz, one word in there, it will be a small break, but it won't break the whole pattern, right? But if this thing happened for millennia, and 10,000 words become 15,000 words, then the pattern will be broken. So what that means is we need something else in going into the model that's not numbers, right? Now you're talking about a vector, right? And that vector is called embedding layer. So that's what embedding layer is doing, which is essentially a matrix that learned the positional encoding of from a token to the next layer of whatever it is you need to predict, right? If it's machine translation, it's predicting another word in another language. If it's text generation, it's predicting next word, depending on whatever task that you're doing. Question? What's that? Is it happening to self-learning? You have to the training data has to see that word before. It's very difficult to just for LLM to magically come up with a new word that makes sense. Let's say let me think about another example. Let's say I'm a celebrity, right? I start a new trend. Like tomorrow, XYZ means you're cool. Instead of saying you're cool, I say you're XYZ. Obviously, ChatGPT doesn't know that because XYZ was never in the domain, was never in the training data. It was never in the corpus. I made it up, right? Same goes with Riz, right? Unless you're saying, what if we don't have the word Riz, but someone right now today, let's say jazz is a word that people use, that jazz looks like Riz. I don't think they do, but just hypothetically speaking, let's say jazz looks like Riz. Is LLM magically gonna somehow stumble upon that next word that happened to be the next trend? There's a small possibility, not very likely that would be the case. You have to retrain the data, and the data has to, the new data that you use to fine tune. What was what? What's the issue of continuing? I'm sorry, what? Ratio? What's the ratio of continuing training that word? That's a good question. I think, like at the scale of what OpenAI is doing, if you just have one word, they're probably not gonna make a huge fuss about it. Unless it's like a year later, and then someone has published like 100 papers in the field that's talking about complete new words in like biology and science and all that stuff. Obviously, when that happens, you want to retrain LLM so that it knows that, okay, these are new words, like all those biological terms, like about drugs, right? When that happens, obviously you want to retrain your model. I would say the ratio will probably be dependent on how many new literature came out. That's like if someone asked me to do that, I will look at the number of literatures, because number of literatures is kind of like an unbiased approach to determine how many new things people made up in the world, right? You don't want to you don't want to fall back too much than the current literature. I think what they're doing today is probably fine tune it once a year. They will probably reissue a new model. But that's based on today's performance. But you've seen what DeepSeek has done. I imagine that will probably happen more and more frequently. Now that we know DeepSeek is able to do this, once a year is probably not going to cut it. Like people are probably going to fine tune it more and more frequently with like higher compute power and lower cost. Yeah, does that answer your question? Okay. Okay, so embedding layer, really down the road is just a matrix. People say embedding, just think about it as a matrix. Matrix can be learned, and what is it? It's learning. It's the positional encoding between words. What that means? It means it's a cyclical rotation in the dictionary. So what does it look like? Well, it kind of looks like this. Each word, you can kind of think about it as an index in a dictionary, right? For example, I have here, this is one of the best films, actually, the best I have ever seen. The film starts one fall day, right? Let's say I have a story, I have a sentence, right? I have a sentence, get rid of the comma, get rid of the exclamation mark, crap like that. I just have words left, right? So these words, in this particular example, let's say I don't have any other words in this universe. Let's say this is the words I have, right? You just count the unique words, and then you'll be able to come up with a vector, right? So 1, 2, 3, 4, 5, 6, this length should be the unique words of this. So this word, maybe it's rank here. This word, maybe it's rank here. This word, maybe it's rank here. You get the idea. This is basically a one-hot encode of your corpus, and it tells you where this word is in that corpus. So this has no semantic meaning at all. If you look at, if this is the Oxford Dictionary, it's literally just alphabetical order, and there's no guarantee that the word start with letter B will definitely happen after the word start with letter A. So that won't work, right? So this matrix means nothing. It's just an encode of your current words, right? So where's the semantics coming? The semantics coming here, the embeddings. The embeddings learns how words cycle. Excuse me, that's the wrong way to say it. How sentence cycle words from a dictionary. Like when I the corpus of dictionary. If your corpus is Shakespeare's poem, then obviously the LM is not going to know anything else other than Shakespeare's poem. So that's why on Hugging Face, you see these standardized data, like, for example, grade school math, that's a data set, right? Alpaca AK is like a Python coding exercise. There's like Wikipedia text, right? That's another data set on Hugging Face. That's why there are these generic data sets that represent the knowledge of mankind. And of course, you can just, or another way you can do is, you can do what OpenAI is doing. So what OpenAI is doing is they work with Scale AI, and Scale AI basically just use crowdsource. And then they put together a giant corpus of data set and question answer pair, and so that you can learn. So all the magic here is saying, hey, look, this embedding layer will carry the importance of the semantics that this vector doesn't. So that's the importance of this matrix here. And then another thing that this is important is after the model is trained, right? After the model is trained, this matrix can then allow you to build embedding layer so that you can convert the words into a vector of numbers. Like if you use bird or tiny bird on Hugging Face, it will convert into a vector of length, I think 764 is one of the base model. There's obviously a longer one, it's 1024. Basically what you're doing is you send the words through this layer, and then whatever comes out of this layer, you take that as the vector representation of the sentence. And then you can do whatever it is that you do, right? Spam detection, you can do sentiment analysis. There's a famous thing that people do online is you can take the the tweets from Twitter, and then you can do a sentiment analysis of basically everything that happened, like starting from 5 a.m. in Twitter. You can scrape it in that time window from 5 to like 9:30 before market opens, and then you shove it in a large language model's embedding layer, and then you do a sentiment analysis of the market. And if that come out to be larger than 50%, then you have a best guess that S&P will probably going to be green that day. People do that. It's actually fairly accurate. So, if that's something you're interested in doing, that's something you certainly can try out. Yeah, that's the important part about that slide. And then, oh, that's a good point. Let me reshare my screen. Thank you for reminding that. Yeah. So for people online, yeah, I record this, and if you're missing something, I'm gonna I have videos about this. I'm gonna send you guys a video to explain all of this. But yeah, eventually, just want to highlight the importance of embedding layer, right? Number one, embedding layer is a matrix, right? Number two, embedding layer carries semantics. The original tokenized vector does not. Okay. So this slide is pretty much what I just said, trying to explain E as an embedding layer. So this is a very, very basic example of how to use a RNN, which is you have time series data. And then here, one small thing you want to notice, actually, let me ask a question. What's the similarity with this data and words? So yes, that's a question I want to ask you guys. If you can see that, then you got it. You understand this whole thing. What's the similarity? What's in common between this? This is obviously not a words, right? This is historical trading statistics. So presumably it's some sort of like volume, stock return. This is return, so this is stock return. This is the volume, so it's trading volume, and then this is the log of volatility, so log of the volume of the standard deviation of stock return. They're obviously not words, right? They're not words. We're not talking about LLM. We're not talking about tokenization. We're not talking about anything like that. But there's a similarity between this data and words data. What's that similarity? Yes, so you're on the right track. Can you explain that? Can you explain that? So,
Together. People just randomly.
yeah, so it's kind of what you said. Yes, so you're kind of on the right track. Yes. One good description here to talk about this data and words data, right? Is actually the positional encoding. It's pretty much what he said. The positional encoding here says this: if you abstract, let's say this one. Let's just use return, because return is easy to understand. So stock return. You look at the price, you calculate the return, right? If today is 200, yesterday is $100, then it's 200 minus 100 divided by 100, right? So whatever that percentage is, that's a return. Okay, so this is a return. If you kind of squint at this, yes, it is a continuous variable, and then theoretically, there should be infinite amount of options here, right? It can be 0%, it can be 0.01%, 0.0001%. You get the idea. Theoretically, it's continuous. There's infinite amount of choices. But is it though, right? In reality, it's not, right? In reality, these are discrete. You're not going to get a 0.000 infinite 1% of stock return, right? In reality, you're just going to round up to 0.01%, right? So meaning what? Meaning this is a finite. So if this is a finite, then if you're going a particular window, let's say past 20 years, then technically speaking, you have a limit and you have a fixed amount of options for this percentage to be. 0.01, 0.02, 0.03. What if I just count them all from minus 50% to plus 100%? And what if I just use that as my dictionary? Exactly. So what if I just use that as my dictionary? Then, yeah, you get the idea. So then the positional encoding, the semantics, they all matter now. So why am I telling you guys this? So I'm telling you guys this for two reasons. Number one, obviously you need to know the similarity. Again, I'm not saying stock data is exactly the same as the article data. Obviously they're different data. But if you just look at the cyclical pattern within a certain window where everything is finite, there is that similarity. And if you can see that similarity, then this whole thing is going to make sense to you. So that's number one. Number two is this is also the reason why you don't do RNN on stock price, because stock price always go up. So if you use a training data in the 80s of say stock price, not the stock return, stock price, and then you train your RNN, and then you're like, oh, I got the accuracy to be super high and the error to be super low. I got it. I'm good to go. Right. Well, then guess what? The model is going to predict like a month accurately, and then in the second month it doesn't work anymore. And then what's going to happen is you're going to have to keep retraining it, and then it probably still doesn't work. And then every month you have to keep retraining it, just keep wasting money. So how it works is you use return, right? And why does return matter? Precisely because of the reason I just said, right? So now you're generating a corpus that at a much longer time frame, at a much longer time window, it's finite in that time window, right? But if you're using a stock price from the 80s, S&P is like $50 or like $10. Obviously, any model here is not going to guess today S&P is 2000, right? It obviously doesn't know that. It's not because you're wrong or model's wrong. It's because that positional encoding was never encoded in the data set. But it doesn't mean stock pattern cannot be learned, right? Stock pattern, it's the cyclical pattern. You can learn from, if I tell you this month it's 1%, next month 2%, you can probably guess the third month it's 3%, 4%, 5%, right? That relationship can be learned. But that's because you already converted the stock price to return, not the original dollar amount stock price. Does that make sense? Any questions? Okay. Perfect. This is a forecast of the log of volume. Again, why do people do log of volume? Same thing, same reason I just said, right? You want to create a data frame such that within that window of training data, you have a finite amount of options, right? You don't want it to look like this, go up infinitely. Like obviously you're not gonna get it, right? Because the prediction that you need the model to learn was never in the training data, right? You want it to be like this. What does that mean? This means it's cyclical. So once you get data to look like that, you can see that the prediction is fairly close to the ground truth. And I believe this is a held out test set. Yeah, it's a forecast. So in terms of volume, it's shockingly accurate, right? And then if you're if you're the guy that knows the model that's here, and then you know this is gonna happen, you don't know it's gonna happen all the way down here, right? What's the, like, let's say stock market tanked to, I don't know what that is. Let's say this is -1. So let's say this is oh, it's log. So you don't know the unit. So the log of shares. So let's say this day it's pretty bad, right? You might not know it's that bad, but your forecast is somewhere here, right? So your yellow bar, it's like here. That it's already higher than all of these guys. So if you have that prior knowledge, then you can get out of your position, or you can even short the market to take advantage of that signal, right? So these algorithms are all out there. If you're interested, obviously, look into that. People do make money out of this thing. My general feeling is it does make money. It will give you good signals once in a while, but it relies on you constantly mining the stock data. You cannot just eyeball it and then make money 1 month and then next month retire. It doesn't work that way. So you have to constantly run your algorithms on these stock data to hopefully one of these days happen, right? So that's the story here, and then that's one good application of RNN. Okay. We have a few minutes left. Let me this is just another way of writing RNN, so let me skip that. Let me talk about this a little bit. This is a very interesting usage of RNN, and then after this, you're pretty much going to get to Gen AI. So let me hopefully wrap things up here for today, and then next time we come back here, we'll be able to talk about more fun things. So this actually came out before OpenAI. The link of paper is actually down here. This actually came out before ChatGPT, before OpenAI do its thing. And then this is actually a very successful application. And this algorithm is going to today's Google Translate on your phone. And it's this is one of the things that, how do you explain that? It's a lot of manpower, a lot of investment, and everybody's using it, but no one's paying for it. It's one of those things, which depends on your perspective. If you're just normal people using Google Translate, you really like it, right? Then you might say Google is a cent that provides this tool for us for free. but if you're an investor that dumped a lot of money here and then you're not getting any single cent back, you might be hating this. So anyhow, what they're saying is a very simple story. So what they're saying is this: they have English and French pair, or English and whatever other language pair, right? And then they are translating on a word-by-word basis. I think later on they figure out a way to fix the grammar. But they're doing, the original paper came out is English and French, because English and French, in terms of the word count, it's very similar. It's much more similar than, say, English to Chinese. So they picked the two language also because both languages are Latin-based, so it shares a little bit of a grammar. So definitely has a little bit of a benefits there. So you can argue that, hey, maybe the data set is curated for that purpose. Maybe it's not because the model is awesome, right? So there, of course you can argue here and there, but when the paper came out, there's always a little bit of a data curation. Does that make sense? So I definitely think there's a value for the model, right? So what the model is saying is this: first of all, it's RNN, right? First of all, it's RNN. What the RNN is doing is it's actually changing the number of hidden nodes when it goes in, when the sentence come out. So when I say sentence, I'm talking about the information in two different languages, right? So generically, you can think about it as the same meaning, but in language 1 and language 2. Language 1 goes into the model, and language 2 come out of the model, right? But how do you know that's the case? Well, you have to go back to this picture and then think about what does one hot encode, what does one hot encoded vector look like between two languages, right? English has this vector for English. French has this gray vector for French. So the only thing different between that same sentence is where that word is in that vector. Like this word, it's in this vector, it's like the third to the bottom, but in French, it might be the fifth to the bottom. And if there's a word-by-word translation, assuming the grammar is not a problem, if you just do verb, that there's no conjugation or anything like that, right? If you just do a word-by-word translation, that position should always have a 1-1 map. Well, obviously, right? Just open the English-French dictionary. Right? There's always a 1-1 map. So that's what that model is doing. That model is able to use the RNN to learn what that 1-1 map is. So it doesn't have to be a human translation or a word-by-word translation. It can be completely be done by a single API call using this model. Other than that, I don't think there's anything too special about that paper. It's just a very a sophisticated using of this data. Obviously, it's curated data, but it is a real data nonetheless. And then they use the entire dictionary, right? There's English, French, English to whatever. So data curation is definitely a big part, real data. And then second one is the design, right? The hidden there's a bottleneck in the hidden in the hidden layer, very much acting like an autoencoder. That's why also people say encoder and decoder. That's where that word comes from. And then it's able to learn the translation. So that's why they call it neural machine translation. And the application for that is it powers Google Translate. Yeah. Any questions? Cool. Okay. So let's stop here, and then let's take a 15-minute break, and then let's come back, and then let's tie everything up. Oh, so like A15, something like that. Let's just do A15. Yeah. Let me show you what's going on. So this is the original paper that came out actually in 2015. So when the paper is published in 2015, that means the model is probably already trained in like 2014 and like 2013, something like that. So based on everything we talked about in class, like this class and previous class, even if you just understand like 50% of what we talked about, you should be able to understand most of what this paper is talking about. So here's how I would recommend read this paper, and then how to make sense of it. So first of all, neural machine translation, the task is language translation, right? So that's kind of like given in terms of what the title says. Literally is in the title. So the first thing I would do is this is if you want to understand the problem in terms of like a mathematical description, then the conventional way to talk about language problem, again, this is before Gen AI, right? Before LM, before Gen AI, is this it's this formula here. It's a conditional probability trying to guess next word conditional on previous word, right? So Y you can think about that as the current word, X is whatever previous word is, right? So you want to maximize that probability, and then hopefully yeah, the higher the probability that you know what the next word is, and hopefully the more accurate the model is. So that's the original conventional approach. So what they're saying right now is saying, hey, look, we know there's this thing called RNN. What we want to do is we want to propose a new design that's encode decode structure, right? And then how that works is you start with a hidden layer. That's what this H stands for. And then it's essentially a function that takes the words and the previous hidden layer. So HT minus 1. So this equation 1, it's a very generic RNN, right? You know RNN, you know what equation 1 stands for. And then how do they make the improvement is on figure 1. Figure 1, if you stare at this figure just a little bit, it's exact same thing as our model. It's exact same thing as what we talked about here, this picture here, except that they have 2 layers in the middle. Their purple circles have two twice, right? So that's what's happening here. So the H1 twice. And then another thing that if you squint at this a little bit, another thing that can be interesting is they have this forward and backward thing going on. Like for example, this X is here, and then you go this way, and then you actually come back. And that's another interesting design that they did. Other than that, not so much of novelty there. This is probably the biggest novelty in this paper. And literally it's just the purple line you repeat twice. That's it. And then after that, these weights, activations, these are all consistent from the previous machine learning model. This exponential thing, this is essentially to find the weights of what each word is given the entire corpus. So that's what this ratio is, and that's what equation 6 is trying to calculate. After that, that's pretty much it. There's really no nothing else need to be talked about. The next thing you read about this paper is data set. So this data set is actually on Hugging Face. I think this is it. I mean, I don't know all you guys, but like I don't know if that's French. Yeah, I don't speak French, so I can't really tell. It looks German. Okay, maybe this data set is German. I don't know if this data set is what the paper is using. This data set is just some random data set on Hugging Face. Maybe it's what they're trying to produce. I don't know. But maybe because this one has 61 million words. They say here it's the WMT14 contains English, French, corpora, and then column, and then these three things are all in there. So presumably this is part of WMT14. WMT14 is just a giant data set, it's a giant corpus. And then it contains EuroParl. And EuroParl, I think this guy on Hugging Face is trying to basically release part of it. Maybe part of it contains German, and maybe that's the original data. I don't know the story there because I haven't fact checked this. But some of this data is on Hugging Face. So you can literally take the model and then grab the data from Hugging Face and then try to reproduce it if you want to. So that's one thing I want to say. When I read a paper, I try to get what the paper is doing, get their model, get their design. Now, obviously, you may or may not understand the design. That's okay. You find the data, and then you go from there. The blue score, it's their performance metrics. I think today there are probably 1 million performance metrics that you can use on large language model. But the original one they proposed in 2015, it's a blue score. Blue score, I did a little research. I think this article talk about here. You're essentially using n-gram framework to trying to check the words. If there's more words that match the ground truth sentence, then obviously the higher the blue score. So n-gram means you can do 1 gram, you can do 2 gram. 2 gram means pair of words, 2 words. 3 just means 3 words, right? And then in the end, you can just calculate the geometric average. And then I think that's the blue score. I think blue score is also customizable. I don't know if this is for its industry standard. You might want to fact check that. I think if you have any metrics, doesn't matter what you're using, as long as you have some sort of good benchmark that you can compare with, then you have an argument. So once you have the argument, then you're good to go, right? Then everything else, you can just release it. And I think they actually have a package here that you can use. Where is it? I think there's somewhere down here, there's a GitHub repo. Here, there's an implementation here that you can use. And then I think on TensorFlow website, you can also, I'm pretty sure there's a neural machine translation tutorial. Neural machine translation. I think it's on, it's one of these blogs that walk you through neural machine translation. That I will find it interesting. If this is something you're interested in, obviously you can take the code and then reproduce it. I think they walk through pretty detailed design of what this thing can do and how you train it. And then somewhere down here, there should be a model.fit. So this is the positional encoding. And then you have a base attention that they did. And then somewhere down here. So this is kind of like already above the original neural machine translation. I think someone else already updated this block a couple of times. The original paper, it should just be an RNN. It's a generic RNN that you can do. And then somewhere down here, there's like a model.fit that you can train it. And another thing that you can use this, on top, you have this Google Colab version. I literally just go in there and run all, and you can kind of like see how the tuning process turn out. Any questions about this? Okay. Yeah, so that's pretty much it. I want to wrap it up here, and then I want to give you guys that knowledge of number one, RNN, how it works, and then what kind of data is good fit for RNN, and then obviously it's time series data, right? And then the third one, which is the last one, is what's the relationship between any random time series data and text data, right? So you should be able to know, at least on a first name basis, you should be able to explain what RNN is, what the logic is, and then how do you go from RNN to language model. We haven't talked about language model, that's fine, but we talk about the relationship, right? At least from data set perspective. So you should be able to say a few words about that. Why is that important? I don't know if anyone is gonna do it. But I've seen people designing agents to design agents to fine tune LLM. Based on everything in this class, you should have the tools to do that. Now, whether you do that for final presentation, that's up to you. But if you want to do that, obviously these tricks are what you want to build into that agent, especially that AI judge should be able to know these things, so that at least you have a knowledge of what to do if you do decide to pick. Let's say you do decide to design an agent to fine tune LLM. That would be one thing you have to think about. So that's it for RNN. Next time we come here, we're gonna pick up from here, and then we're gonna basically drive it further into Gen AI world. So today is kind of like a break. Before today, it's conventional deep learning. After today, it's more like Gen AI, which is very much like today's AI. So today's lecture and previously, we're talking about AI that's maybe like 10 years ago. After this next lecture, when we come back, will be about AI that's like maybe next 4 to 5 years. Sorry, recent 4 to 5 years. Make sense? Cool. Any questions? Awesome. That's it for today. And then I'm gonna send out an announcement for the deliverable.